Hello and welcome to CoolSim. This demonstration is to show you how to quickly get started with the CoolSim application. As you can see, when CoolSim first comes up, it comes up in two windows. You can adjust these windows with the center slider bar back and forth. They are the same, it's just a different view of the same exact environment. The system will come up with a raised floor data center. That's the default. This can be changed by simply double-clicking any object in the room. In this case, I double-clicked on the wall. And we're able to change this to anything we like. But for now, we'll just leave it as a raised floor data center so that you can see how the system basically works. You'll notice in the upper right-hand corner, there are three icons. These are for viewing. You can view the system in single mode, such as this one. This is a single view mode. In the upper left, you see me pointing at something that has a pull down. You can always change this top view to perspective, or any of the others, bottom, top. The two that are most commonly used are top, which is how many data centers are documented, and perspective. And you can run it in split screen if you want, and change each one of these individually to be whatever you like. The third one is for dual monitors. You'll notice it is turned blue in my case because I do have a separate display. If I select that icon, a second window, an entire window will pop up, and I can shift this into perspective mode and slide it over onto my other monitor, and then I can leave this one back in regular mode over here. So now I have a 3D view and a single view over here that I can use concurrently. Okay, I'm going to turn that one off for now and just use the single view. So here's the CoolSim model in single view mode. Here's perspective. As I mentioned to you, all objects in CoolSim have an editor. So you can edit any of the parameters in CoolSim at any time. This includes the room, the definition of the room, and everything else that goes with it. Along the top, we have a selected set of icons. You notice there's not very many. We do this intentionally because we're trying to keep this interface nice and simple to use. Everything you'll need for CoolSim is in these icons or in the simple edit commands. So we have a simulation only has 2 picks, and edit has a few, and then file of course has a few too. Help is here. You can always go to help and go to our online training. We also have an AutoCAD tool for importing from AutoCAD. But for now, I want to show you the options. Here in particular, units. You're going to want to set your units. I currently have my units set for custom because I typically work in the US where the units are in fact mixed. You notice cooling capacity is in kilowatts, which is not an English metric. In the United States, they mix their units, so kilowatts instead of tons, and inches of water, interestingly enough. Feet, square feet. This one is showing wall resistance. That's usually in BTUs for US, and kilowatts per ton for efficiency. So set these the way you want them. I have it set for CFM for flow rate. In addition, you'll have already put in your authentication. Your authentication is right here. Okay. Now, once you have this set up, the rest of it is just simply drag and drop to build. Remember that you can double-click, left mouse, double-click to open the editor to change the room. I recommend you get the room set up properly first before you start putting equipment in it. You have options here of ceiling plenum return or non-raised floor. Hitting the apply button will cause this to take effect. So here I've added a ceiling plenum to my design. The ceiling plenum is not very deep in this case, so I just double-click again. I can change all of these parameters. I can change the ceiling plenum height to 4 feet. I can change the room height to 12 feet. Just change the size of the room to 40 by 40. And when you apply these changes, it will update that room. Okay. We also have here specifications such as altitude, tiles, different size tiles. If you're running a metric, for example, you'll be using 60 by 60 tiles, possibly. Adjacent room temperatures, we only have one for all walls at the moment. Okay, now to get started building, it's a drag and drop. the origin for CoolSim is upper left-hand corner. That's derived from Fluent. We are a Fluent shop. The back end to CoolSim is really Fluent's, and that has its origin in the upper left-hand corner. It's a right-hand coordinate system. You see in the lower left-hand corner there's a small representation of that. So X is to the right, Z is down, and Y is straight up out of the page. Right-hand coordinate system, X into Z gives you Y up out of the page. So when you're dragging, and to drag something you simply select it. I'm going to drag a crack unit. Crack is a computer room air conditioner. Left mouse down, or equivalent. You drag it and you let go with the left mouse to where you want it. There it is. Now if I have that in 3D mode, if I click it into 3D, you'll notice there's a plenum extension on that cooling unit, because CoolSim is fairly smart. It recognizes that you probably want a ceiling plenum in place. You'll notice the arrows here indicate air travel direction, so this is a downflow unit, because the most typical kind of cooling unit in a raised floor design with a ceiling plenum is a downflow, and they are typically connected to the ceiling. Again, this is just a default unit. You can make it anything you want. You can also choose from the library of objects we have. If I double click on that object, a room editor will open, and that cooling unit editor will allow me to change anything about that cooling unit. I can rename it. I can change its direction from downflow to front flow if I choose. If I do choose to do that, it will turn off the turning vane. Under geometry, there's flow direction, plug fan capability, supply return parameters. Under thermal, there's the different types of flow methods, including airflow rate, supply temp, cooling methods, different cooling methods here. We default to supply temp. And we'll just leave it for now with a supply temp of 65 degrees. And we also have on-off. If you scroll down, and we have on-off features. You can turn it off or turn it on, or you can make it a fan only. If it's a fan only, then it doesn't dissipate any heat. It just moves air through it at a rate that is set by these parameters. So that's how cooling units work. All objects are essentially similar. If I bring in a rack here, I get the same effect. So I just dragged it in and dropped it. The default is 5. No particular reason why. Racks, again, to edit the parameters, you simply double click it and open them up. So here I've double clicked on rack and I'm opening the editor. The editor will pop open and I can make parameter changes, including things like quantity. So I can take it down to 1 unit if I want, start position, height, and of course specification. I can put a vertical exhaust duct on it if it were of a particular type. Types are front to rear, front to top, front, rear to top. Specifications are here. It defaults to 4 kW or rack. This assumes average heat dissipation across the rack with an expected temperature rise of 25 degrees Fahrenheit. Again, you can modify all of these parameters, including what's in the rack. At the moment, it assumes even distribution of heat across the rack. But it doesn't need to do that. You can check the individual rack specification flag, open the original individual rack specification tool, and you can take that 4 kilowatts and actually distribute it. These are meant to indicate they are U's. So this is a U. You can see it's a 48U rack. It's a 7-foot rack. We number them in CoolSim with 1 at the top for no good reason other than it was easier to implement. So you can grab a couple of U's here. I've just grabbed 5 U's and say my server is located there. So here I've got a 2 kilowatt server with a 25 degree. You can also color this or change its name to whatever you like. And so let's say that I have 4 kilowatts, but they're actually distributed non-uniformly. So they're actually 2 and 2. So they're located in different positions in the rack. And let's say also that the user forgot to, in this case, put a blanking panel in place. So here I've got a gap that I can put in of 4 U's. And so my point here is you can make these racks as detailed as you want to make them. In this case, I put 2 servers in and a hole in the middle so that I can indicate through simulation how bad an idea that is. We also have HDUs. That's a heat dissipating unit. This is a bottom to top device. So this could be a PDU or an RPP or anything. You notice when I drag it in, it's not sitting directly on the floor because that's an inlet down there, and if I had it directly on the floor, it would block that inlet. So it's up off the floor. Again, this can be edited. You can make this anything you want. Remember, folks, that the specifications on this relate to heat dissipation, not the total kVA that this unit can handle. This might be a 100 kVA unit, but its heat dissipation is going to be about 2% of that. So it's not unusual. We defaulted to 1 kilowatt. It's not unusual for this to be 1 or 2. This is the heat dissipation associated with that unit, not its handling capacity. Just to let you know. We have other objects like rectangular blocks. This one came in as a column, but it doesn't have to be a column. Again, I double-click to open the editor for this, and I can change this to a column or a overhead cable tray or an underfloor cable tray, or I can put it in the room. Right now it's a column, so it goes slab to slab. If this is a non-raised design, it would go right from slab right through the ceiling. If it was raised floor, it would do the same thing. Columns go from slab to slab, where in room sits inside the room, of course, from ceiling to raised floor. You can generalize it, make it anything you want if you want to use it for general blockage. Overhead cable tray, underfloor cable tray. Cable tray is just a block that's set at a certain height. Okay. We also have circular blocks if you want to simulate pipes, underfloor obstructions. They also can be changed. The orientation can be changed so they can be in any axis that you would like them to be. For example, we can make it in the room. We can make it general, for example, and change its height. We can change its orientation so it's vertical, and set it so that it goes vertical. And then we can change its height, for example, and turn it into an STK silo or whatever it is you want to make it using diameter. So we'll put in a diameter of 3 feet just to show you how that works. Okay, so round objects are not a problem. We also have polygon blocks in case you want to do angled rooms. Angled rooms are done by blocking out sections of the room. We have baffles. Baffles are very handy. They allow leakage to occur, so I open this editor and you can see that it allows air to flow through it. It's currently set for 5%. Very common for creating containment using that method. You can also rotate them by, in this case, I right mouse and I can rotate on the axis where my cursor was, so I can modify this in any direction I choose and use it for things like diffusers or angled baffles, whatever you like. We have a grill tool. You'll need grills in your ceiling. The ceiling is made transparent. So in this case, I have a ceiling that I can connect to the cooling unit if I want to, and use this for ceiling level return. If it were a non-raised floor design, I would have perforated tiles over here and cable cutouts. They're both grayed out because I happen to set it up as a non-raised floor data center, so those don't apply. And we have duct tools. So if you want to build a ducted system, we have a fluid duct that allows you to create the duct. I'm not going to go into that in a lot of detail at the moment because there is a tutorial on that by itself. So that's basically how you start to build your data center in CoolSim. We have very nice tools to help you along the way, such as Control-C, Control-V of objects, so you can duplicate them. We have a grouping feature, so all I did there was point at an object and used Control-C, Control-V. We also allow grouping. So you can group 2 objects together. I just held my left mouse, used the control key to select both of those objects. Then I can right mouse it and group it, and now it's an entity, or an assembly in this case. I can also clone that. The clone is a very handy tool. I'd recommend you get to know it. clone allows you to take an object or a group of objects and offset them in X, Y, and Z with a copy. This is very common in data centers, lots of symmetry in the data center. So once you've set up your first, what we call a pod, which is often a set of racks, often containment, often tiles, floor tiles, or hot aisle containment, ceiling grills, you can select that entire entity, group it, and then clone it. It saves you a tremendous amount of time. The rest of it is fairly straightforward. The pre-simulation report I would draw your attention to just to make sure your numbers always add up. In this case, my racks want 1,000. I'm delivering 4,800. This is the most important set of information right here. You must deliver. It is a closed system. You must deliver enough air to satisfy the requirements of the racks. Otherwise, it's not going to perform well. The plot setup is defaulted. You don't need to do anything here. Once you've made a run, you may want to modify post and change some of the parameters in post. You may want to change the position of the cut planes and so forth, but you can do that all after you've made a completed run. And to submit the simulation, you simply hit the run button. And that will connect you to the internet. It will tell you how much capacity you have, and will allow you to submit it. Okay. When the run is done, you'll get an email back, and it will tell you you can download the report, or you can just hit the status button, and it will tell you what the status is of your simulation. If it is complete, it will download it and put it in this tab down here in the lower corner. I'm down in the lower left corner now, and you see there's two tabs. There's a design tab and a report tab. The report tab will contain all of the output for this particular model that I have not yet submitted. But once it's complete, all the output will reside in the report file. So that's a quick overview of CoolSim, enough to get you started. And we have another series of small videos that we have in place for you to watch to learn how to do specific tasks like setting up racks, setting up cooling units in detail, using the ducting tool, etc. They're all fairly short. I would encourage you to take a look at them. Thank you.